So before anything else, let me introduce to the topical workbook for Computer Science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. I hope you guys are doing great and you have understood everything so far. So moving on, let's get on with the other the next part of section 4.2, that is electrical quantities. Next up ahead we have electrical current. Current is simply the rate of flow of charges per unit time, hence given by the formula I or current equals to Q, means charge upon T, time. SI unit is supposed to be ampere, capital A. It can be measured using an ammeter which must be connected in series to the circuit. You'll get to understand the idea of what series and parallel in a while. A current of 1 ampere is a flow of charge at the rate of 1 coulomb per second. So if 1 coulomb charge is passing through a circuit every second, then we say that circuit has a current of about 1 ampere. For the electrical current in a metal conductor, the charge carriers are electrons. The direction of the conventional current is always treated as opposite to the direction in which electron move. Electric current generates a magnetic field whenever it moves. The strength of the magnetic field depends on the magnitude of the electric current. If the direction of the current is fixed, it is known as a direct current, whereas if it keeps on changing, it is known as alternating current or AC current. Batteries always give DC voltages. Generators, on other hand, can produce either DC or AC, depends upon how they are designed to work. The number of complete alterations or cycles in 1 second is the frequency of an alternating current. The unit of frequency is hertz, and the main supply in our homes is usually at a 50 hertz frequency, means that the electricity in our homes have a frequency of about 50 hertz, means 50 complete cycles or 50 alternating signals are produced every second by that electricity. Electromotive force, or the E.M.F. It is the energy that is converted from chemical or any non-electrical source to electrical source when 1 coulomb of charge passes through the source. Its SI unit is volt. denoted by symbol V, whereas the EMF or the energy is given by W upon Q, work done upon charge. Q is supposed to be the amount of positive charge and W is work done. The volt can also be given by joule upon coulomb, but that is not really very, that unit is not very rarely used, and volt is the common unit. The potential difference between 2 points is defined as the amount of energy that is converted from electrical to any other form. When 1 coulomb of positive charge passes through 2 points, its unit is also volt, and its formula is the same as work done upon charge. W is the work done in driving the charge, and whereas Q is the amount of positive charge. Note, there can be EMF without a closed circuit, but there cannot be a potential difference without a closed circuit. For a potential difference, the circuit has to be closed, it has to be complete. Now, what is basically the difference between EMF and PD, potential difference, and electromotive force? The dissipation of electrical energy between 2 points, for example a light bulb, a buzzer, a speaker, etc., in an electrical circuit causes potential difference between these 2 points. What happens is that when some current flows through any electrical component inside a circuit, then that component takes up some of the current for itself in order to run. Now when that component takes up the current, then this basically means that the amount of current going into that component is not same as the amount of current going out of that component, because some of it has been used up. Now this causes a difference of voltages, a difference of you can say current, a difference of voltage, a difference between energy level between when the charge was entering a component and when it was leaving a component. Hence it is known as potential difference, the difference of how much energy was used up by a component, whereas EMF is simply the amount of energy that is produced by an electrical source such as a battery or the mains. SI unit of potential difference is also volt, and the EMF is also volt. Both are measures of electrical potential energy. EMF is the gained electrical energy, whereas potential difference is the lost electrical energy. Hence, that's why they have the same formula. Measuring potential difference. How you can measure potential difference across a component or across 2 points? It can be measured using a voltmeter that is connected in parallel across the component. Means if this is the component, then one wire of voltmeter is connected to its one end and the other is connected to its other end. This is known as connecting something in parallel. Voltmeters are of 2 types, digital or analog, and they should always be connected with in parallel with other objects. The potential difference is the difference in electrical potential between 2 points. Therefore, the voltmeter has to be connected in parallel or to those 2 points. Analog voltmeters are subject to parallax error that we have discussed in section 1. So you always have to read the meter from a position directly perpendicular to the scale. Always double check exactly where the marker is before an experiment. If it is not at 0, you'll have to adjust your final reading accordingly. These are some helpful tips for solving out P4. And analog voltmeters should always be checked for 0 errors before using. The digital voltmeters can measure very small potential differences as well, in microvolts or millivolts. They are more accurate than analog displays. This is millivolt and this is microvolt. They are easy to use because they give a specific reading and you do not have to look at a moving needle and try to decipher the exact value for it. They also display more precise values. However, they are very sensitive, so they tend to flicker. The reading keeps on changing, so it can be a little difficult to decide which reading to take. Digital voltmeters should always be checked for zero error, and if they have a zero error, then you'll have to adjust it. If you don't know how to do that, then you'll simply have to go back and you'll have to watch the lecture for section 1 and you'll know how to fix zero error. Example question: a battery of electromotive force 10 volt is connected to a resistor. A charge of 2 coulombs pass through the resistor. How much work is done as the charge passes through the resistor? Now we only have a single formula that connects charge and voltage together. That is E.M.F equals to Q upon T, work done upon time. Now we have to find how much work is done, so E equals to W upon Q, sorry, not T, W upon Q. So we know the value of Q, that is 2 coulombs, and we know the value of E.M.F, that is 10 volt, but we don't know the work done, so we'll simply cross multiply. W equals to Q into E, and that means 10 multiplied by 2, D should be our answer, that is 20 joules. Since it is energy, so we'll give the answer in joules. The sun produces a solar wind, which is a stream of charged particles. In one part of space, the solar wind is due to the movement of protons and alpha particles away from the sun. A charge of 180 coulombs passes through a small volume of space in 2 minutes. Calculate the electric current in this volume of space. Now the formula that connects current and time, we are given time in 2 minutes, and the coulomb or charge is supposed to be I equals to Q upon T. So simply plug in the values. We have to calculate I, or the current. So Q is supposed to be 180. However, if you remember, current is supposed to be number of charges per unit time, per unit second, or per unit time, or every second. Now over here we are given the value in minutes, so we'll have to convert it into seconds by multiplying it with 60, because in 1 minute there are 60 seconds. So 180 divided by 120 means 2 into 60 would give us 1.5, and the unit for current would be ampere. Next we have sources in series, or cells connected in series. When 2 or more cells are arranged so that the positive terminal of each of them is connected to the negative terminal of the other source or cell, they are said to be connected in series, and their EMFs add up. This happens because the charge flowing around a circuit will pass through more than one sources and gain extra energy each time they pass through a source or a cell. Sources can also be arranged in parallel, where all the negative terminals are connected together and all the positive terminals are connected together. In this case, the EMF remains the same. However, the battery lasts longer because it will have more backup power. These are the cells connected in series. As you can see, there are 3 cells of 2 volt connected, so the total output would be 6 volt. These are cells or sources connected in parallel. Now when a charge comes, it will be divided. It will go from over there, over here, and over here, and when it would go through different paths, the total EMF, or the total difference between 2 points, would remain the same. Between over here and over here, between these 2 points, the PD would remain the same. If it takes this path, then again the PT would be same. If it takes this path, again the potential difference would be same of 2 volt. Now why this battery lasts longer? Because naturally when a charge is coming, then it takes the first or any one of the paths. Once this battery is dried up, then it still has 2 paths from where it can gain some electromotive force. So it will go through this path. Once this is also dried up, it will still have one last path to go through and gain some energy from. Hence this setting would last longer and this would not. Resistance. Resistance of a conductor is defined as the ratio of potential difference across the conductor to the current flowing through it. Means resistance is supposed to be V divided by I. SI unit of resistance is known as ohm, and the symbol for ohm is supposed to be this, the omega symbol of Greek, and we usually connect it with the formula V equals to IR. Now where this formula has come from? It has come from the Ohm's law, which states that the current flowing in a metallic conductor is directly proportional to the potential difference applied across it. This V is directly proportional to I, and when we remove this proportionality symbol and introduce a constant, then that in this equation that constant is R, the constant of resistance, and we get this formula V equals to IR, provided that physical conditions such as temperature remains constant. This is a diagram depicting Ohm's law. Ohm or resistance is basically a property of a material to resist the flow of current through it. Volt is basically the energy that moves the charge or the ampere or the current around a circuit, whereas resistance is the property or that tries to slow down the speed of said charge. Thus R must be constant for a metallic conductor under steady physical conditions. Resistors are used in circuit to control either the current in branches of the circuit or the potential difference or voltage across certain components. This is due to the consequences of Ohm's law. The current in an electrical conductor decreases as its resistance increases because V equals to I equals to V upon R. So current and resistance are inversely proportional. Whereas the potential difference increases as the resistance increases. Why? Because V and R are directly proportional. Besides temperature, experimental results show that resistance also depends on composition and size of the material. R is directly proportional to R is found to be directly proportional to the length of the conductor, inversely proportional to its cross-sectional area, and it also depends on the type of material. From experiment we can show that R equals to rho LA, where R is the resistance in ohm, A is the cross-sectional area of the conductor in meter square, L is the length of the conductor in meter, and rho is the resistivity of material in ohm meter. This formula is important from exam point of view, so you should really learn it. Thinner wires have higher resistance than thicker wires because cross-sectional area is inversely proportional, and similarly thickness and material, longer wires have higher resistance than shorter wires. Measuring the resistance of a conductor. This is an experiment that might come in your paper 2 or paper 4. The resistance R of a conductor can be found by measuring the current in it when a potential difference is applied across it, and then using the formula R equals to V upon I to calculate the resistance. This is called the ammeter voltmeter method, and if you are doing this experiment, then for P4 remember a safety measure. You may be asked to write it down. Do not touch the wire while the current is flowing through it, as it might become hot and it may burn your hand. When a conductor has higher resistivity and a current tries to pass through it, then it becomes hot or its temperature increases. Now this is a supposed diagram of such a circuit that can be used to find the resistivity of a conductor. We use battery that is connected in series with ammeter and a variable resistor. Variable resistor is an electrical component which has a knob on it, and by moving that knob you can either increase or decrease its resistance. Then we connect voltmeter in parallel, whereas there is also a switch to turn on or off the circuit, and then we have a piece of wire. Altering the rheostat means the variable resistor changes both the potential difference and the current in the circuit. So what you'll need to do after setting up this diagram, or after setting, if you are already given this diagram, then what you are going to do is you'll have to draw a table with at least with 3 columns and at least 5 values, taking different values for V and I by adjusting the variable resistor, and then in the third column you'll use the formula for resistance to calculate the value of resistance, and by doing that you can state what is the relationship between the length of this wire and the resistance of it, or the if given the cross-sectional area. Next, you need to know the current and voltage characteristics graph. As the potential difference across a component is increased, the current in the component also increases. The precise relationship between voltage and current can be different for different types of component. So you simply need to learn the shape of these graphs. For a ohmic conductor, means a conductor that follows Ohm's law, the line would always be straight. For a filament lamp, the line would be slightly curved. For a diode, the line would be like this. Okay, you'll need to remember it. As the potential difference across a filament increases, the current increases and the energy as heat also increases, resulting in a higher temperature, which causes the resistance to increase, and the collision between the free electrons and the lattice ion increase due to more vibration of the lattice ion. This causes the graph at the end to become non-ohmic or non-linear. Example question. And about the diode. Basically, diode is a component that only allows current in one direction only. So there is no graph in the other quartile. When it is connected in the right direction, then at first it resists a bit and then it starts conducting. Example question. The 12-volt battery is made from cells of electromotive force 1.5 volt, which are all in series. Calculate the number of 1.5 volt cells that make up the battery. Now they told that the final output is 12 volt and each cell is 1.5 volt, and since they are connected in series, so how you find the number of cells? Simple. Divide the total EMF divided by EMF of one cell. So 12 divided by 1.5 gives you 8 cells. State the EMF of a battery made by connecting all of these cells in parallel. Whenever you connect cells in parallel, the EMF remains the same as any one of the cells. So that means 1.5 volt. A copper wire has resistance R. Another copper wire Y has twice the length and half the cross-sectional area. What is the resistance of Y? Now the answer would be B. Why? We'll apply the formula over here. R equals to rho LA, and over here, now let's take some supposed value. Let's say that P is 3, L is 2, and A is, let's suppose, 4. Okay, now for X, PLA, 3 multiplied by 2 multiplied by 4 would give you 3 2 is 6, 6 4 are 24. And for Y is supposed to rho resistivity would remain the same. Now the length is supposed to be twice that, so L instead of 2 it would become 2 2s are 4. the cross-sectional area is A upon 2. Over here this is 4, so it would be divided by 2 and it would become 2. 3 4s are 12 into 2, 24. See, you get the same answer. So they both would be R. So the answer would be B. The voltage across a resistor of fixed resistance changes. Which graph shows how the current in the resistor changes with the voltage? Now a resistor is supposed to be an ohmic conductor, or a conductor that follows Ohm's law, and as you know, in a resistor at constant temperature it is always a linear graph. When the current increases, so does the voltage, and vice versa. So without any doubt you would pick A. That's it for section 4.2. I hope you have understood everything. If you have any problems or confusions, do write them in the comments below and I'll reply to them. If you have understood everything, then just give it a thumbs up below in the comments and share it with your friends. I'll see you guys in the next lecture. Take care. Allah Hafiz.